Alright, starting lesson 7.3. Now we are working with multivariable linear systems. So we're working with more than two equations at a time and more than two variables. Okay, so example 1. Let's see how we approach this type of problem. I suggest labeling each of the equations. 1, 2, 3. And for equations 1 and 2, I'm going to cancel out the y. So I have equations 1 and 2, x plus y plus z equals 6. I'm going to put a horizontal line through the z so you don't confuse it with the 2. Okay, now the y's cancel out. Add these up, and I get 3x plus 2z is equal to 9. Okay, now I'm going to take equations 2 and 3, and I want to cancel out the same variable. I'm going to cancel out the y. Alright, the y's cancel. But what's nice in this case is that the z's cancel as well. So I'm left with 5x equals 5. Okay, then I could solve for x right away. So x equals 1. That's pretty nice. Then I'll just plug that in over here and solve for z. Alright, subtract 3. 2z is equal to 6. Divide by 2, and z is equal to 3. Alright, I have x and z. Now I could just plug them into, say, the first equation here and solve for y. So I have 1 plus y plus z, which is 3, is equal to 6. So I have 4 plus y equals 6. Subtract 4, and y is equal to 2. Alright, so my answer then is a point. First comes x, second comes y, and third comes z. Alright, so the point 1, 2, 3. That's a three-dimensional coordinate system. Alright, let's do one more example. Alright, same approach as last time, or last example. I'll label all the equations. Okay, I'm going to choose equations 1 and 2, and I'm going to cancel out the z's. So I'm going to have to multiply the first one by 2. Alright, the second equation stays the same. Okay, so I'll just put the first equation on the bottom of the second. So I have 6x plus 8y minus 2z is equal to 34. Alright, so I add the x's up, I get 11x, the y's, I get 7y, the z's cancel out, and I'm left with 32 here. Okay, and then I'm going to choose equations 1 and 3. Alright, now you don't have to go with the same equations. Alright, you could use a different set of equations and still get the same result. In this case, I'm having to multiply by 7, so I cancel the z out in the first equation with the 7z in the third equation. once again, I'm going to take that first equation and put it below the third. So 21x plus 28y minus 7z is equal to 119. So I get 23x and then plus 25y. These cancel out. I'm left with 98. Okay, so what am I going to do next? Alright, so I have 11x plus 7y equals 32. And the other equation, I have 23x plus 25y is equal to 98. Alright, so what am I going to do here? I'm going to cancel out the x's. So I'll multiply at the top by negative 23. And the bottom by 11. And I end up with negative 253 x minus 161y is equal to negative 736. And for the second equation, I get 253 x plus 275y is equal to 1078. Alright, adding them up, I get 114y is equal to 342. Divide by 114, and that actually goes in there nicely. Y equals 3. Okay, cool. Now I'm going to plug this into this equation here. So I get 11x plus 7 times 3 equals 32. Okay, just take your time doing the math. It'd be a shame to do all this work and then goof just because you made a minor calculation error. X equals 1. Alright. Now I gotta solve for z. And I'll use the first equation I started with in the very beginning. So that's going to be 3 times 1 plus 4 times 3 minus z is equal to 17. So I get 3 plus 12 minus z is equal to 17. 15 minus z is equal to 17. Subtract 15. Negative z is equal to 2. Divide by negative 1. And z is equal to negative 2. Alright, so my answer then is the x, which is 1, the y, which is 3, and z, which is negative 2. Once again, this represents a point on a three-dimensional grid. Alright, there's not much to it. It's pretty simple. You just got to take your time working out these problems. If you need any help, please make sure to ask for it. Begin the assignment.